Hey, flipped chemistry, how you doing? Are you having a wonderful time in chapter 3 yet? I know I am. I'm just loving this stuff with math and numbers. So significant digits. You guys have had a little bit of an exposure to it. You outlined the part of the chapter that has to do with the introduction of all the formal rules for significant digits. I'm going to touch on another way of looking at that that's a lot simpler, and hopefully help you clarify that concept, and then show you how to do some rules with math, and then we're going to be moving right on through. Now, let me just give you a word of comfort right now. If after the end of this lecture you are scratching your head like this dude here, and you're not totally confident that you understand the idea, let me give you some peace. It's okay. You are going to be doing this so much that it'll come as second nature to you. I promise you will understand. It's like riding a bike, right? If the first couple times you fall off, and your dad is still running behind you holding the seat, and he says, okay, now go, and let's go, and you fall on your keister. By the time you've fallen down 100 times, you can ride a bike. Eventually, everybody can ride a bike. Eventually, everybody learns how to tie their shoes. Eventually, everybody knows how to do significant digits. So you will get it. It's okay. Here you go. Let's move on. Significant digit rules. Now, you had more rules than this from your textbook, but this is the easier way to go. Leading zeros are never significant. Never, no, not never. Can't be significant. If it's in front of the first non-zero digit, doesn't matter, right? Leading zeros don't count. Trailing zeros only count if there's a decimal point. So in the number like 700, and if I don't put a decimal point after it, it's just 700, then there's only one significant digit. The trailing zeros don't count unless there's a decimal point, okay? Then the third rule is that all non-zero digits, or any zeros that are in between non-zero digits, are significant. Those are the ones that matter, okay? So let's look at some examples here, shall we? Here we have the number 365. How many days in a year? 365. How many times will you need to watch this video before you understand? Hopefully not 365. Okay, 365 has no leading zeros, no trailing zeros, no in-between zeros, so that's pretty easy. There's 3 numbers there, right? So it has 3 significant digits. No problem. Let's look at another number, 1200. No leading zeros, does have trailing zeros. And in this particular example, there is not a decimal point. So this has 2 significant digits, okay? But this time, 1200 with a decimal point. Now, no leading zeros, trailing zeros, but trailing zeros are significant if there's a decimal point. So 1, 2, 3, 4, 4 significant digits. You tell me on this one. I'll stop here for a minute. How many? I hope you said 1. There are leading zeros. There is a decimal point, but that doesn't control leading zeros. Leading zeros are never significant. No, not ever. And so, they're only the 3 matters. 1 significant digit right there. Okay? How about this one? Did you say 5? I hope so. 1, 2, 3, 4, 5. The zeros here count because they're in between non-zero digits. Okay? 5 significant figures. How about this one? Did you say 4? I hope you did. 1, 2, 3, 4 significant digits. These guys are trailing. They don't matter. There's no decimal point. Okay? And last one. The answer is 7. Because all of these trailing zeros count. See that decimal point? It makes trailing zeros count, even if they're trailing after the decimal point. Okay? So 7 significant digits there. Alrighty. Moving on. A good way to express how many significant digits you have in a measurement is to write it down with scientific notation. Now, you've done this before in math class. You've done this before with physical science. This is review. And so scientific notation, you express only the significant digits, and you express them as a number, point numbers, and then multiplied by 10 to some power. And that power tells the reader how many times you move the decimal point to make that number what they're looking at, right? So again, like 1.563 times 10 to the 12th power would be 1563 followed by 9 zeros. But all the 9 zeros are insignificant. So I just put the numbers that matter and put a decimal point, and tell the reader how many times I moved that decimal point. Okay, you've done this before. Let's show you some examples, or have you show me some examples. 1,458,000. That might be the number of breaths that I've taken this year. I don't know. Big number. How many significant digits are there? Well, there's 4, because all the trailing zeros don't count. There's no decimal point. So if I want to help my reader understand that there's only 4 significant digits, and it's just that 1458, that's all that's significant, then I'm going to write 1.458, right? And then I'm going to tell the reader, but it's not really 1.458. It's 1,458,000. So I moved the decimal point 6 times to get it there. So I'm going to indicate that by multiplying it times 10 to the 6th power. Okay, this 6 represents these 6 digits that I had to move the decimal point past to make this number. Look at another one. 17,362 and 12 zeros. I don't even know what that number would be called. Huge number. My significant digits are only 5 numbers, 17362. And so I'm going to say 1.7362, all my significant digits, times 10 to the, I moved it 16 times, so times 10 to the 16th power. Look at another one. Here's this number, 0.000024. I moved the decimal point 6 times to make 2.4, but I moved it to the right, not to the left. So I've got to represent it as times 10 to the negative 6. Okay? Now, look at this number. Put that in scientific notation. You should have done this. 1.9655 times 10 to the 17th. The significant digits are here. All of those are insignificant. Keep the significant digits. Tell me how many times you moved the number. Okay? Here's another one. Pause the video while you work on that. And the answer is 2.145 times 10 to the negative 8th. Here's my significant digits. Put a decimal point here. I have to move it 8 times to the right to get that number. So that is the expression here. Okay? If you need more examples, there's scads of these online and lots in your books, and we'll do a couple in class too, so don't worry. Alrighty. I hope now you're like this little baby and you understand. Last thing, here's some math rules for you while you're doing math with significant digits. You need to express your answer to reflect the least accurate measurement that you have. If you measure several things, and on a couple of the things you're able to measure to 6 digits, and on some of them you're able to measure to 8 digits, and one time you can only measure to 3 digits, well, you need to present your answer after you've done all the math with these things to only 3 digits, because you want to tell the reader your least precise measurement. Okay, this is, you could tie this into the Bible. You could talk about giving an honest answer, about not puffing yourself up and saying, oh, I'm so smart, I have 45 digits. No, you only have 3. So you need to make sure that your answer is expressed in only the least number of significant digits that you have. Now, when you're adding and subtracting, it's a little bit different, because when you add or subtract, you just line up the decimal point and you express your answer with the least number of decimal places that you have. So that's pretty simple. Let me give you a quick example so that you understand. If you're adding these numbers up, and these are all measures, right? This number you only measured to the 10th place. This number you measured to the thousandths, and this one you got measured out to the hundredths. Well, you need to express in the least accurate. So when you add them all up, you look back and you say, oh, only 1 decimal place. I got to only say 1 decimal place. So this is the answer that you would report, right? For multiplication and division, you don't line things up like that. And so for multiplication and division, you just need to make sure that your answer has the least number of significant digits of any of your measured data that went into it. Now, a couple of things that make it a little bit different is conversion factors or counted numbers do not affect significant digits. So if you've got things that are measured and then you're multiplying it by something that you just counted. Hey, look, there's 6 of those. The 6 is 1 significant digit. You don't have to say there's 6.00000 of those. That's silly. That doesn't affect your significant digits. Look at measured data only to control your significant digits, okay? And then don't round until the end. Don't, if you have a 5-step problem, don't round at every step, because then your answer is going to be rounded multiple times and will probably be wrong. Do all of your math with all the digits that you can. And then before you write down your final answer, look back at your measured data, see how many significant digits you had in your least accurate measurement, and express your answer in that many digits. Okay? Saves you a lot of headache and a lot of missed answers on tests. Okay, there you go. That's it. Math and measurements. We will do so much of this. It's going to be amazing. So you will understand. I believe in you. God bless you. See you tomorrow.